Hello everyone, my name is Arpit Singh and in today's video we are going to see solution of third internal test of numerical analysis and design. The first question is write an algorithm to solve simultaneous linear algebraic equations using Gaussian elimination method. The algorithm for solving simultaneous algebraic equations using Gaussian elimination method is like input the number of equations and we have to first take input how many number of equations there are going to be. Then we augmented matrix, we take input of A with the size of n cross n plus 1. By using forward elimination, we use two loops for k is equals to 1 to n minus 1 and for I is equals to k plus 1 to n. We compute factor f which is a the value at I cross j divided by a the value at k cross k. For j is equals to k to n plus 1, we compute value a I cross j equals to a I cross j minus f into a k cross j. This computes the forward elimination for the augmented matrix. The back substitution is like we take an array in which x, the nth position is equals to a n cross n plus 1 divided by a n cross n. For I is equals to n minus 1 down to 1 in steps of minus 1, we initialize sum is equals to 0. And for loop j is equals to I plus 1 to n, we initialize sum is plus is equals to sum plus a I cross j into x jth position. And store value xi is equals to ai n plus 1 minus sum divided by aij. We then output value of xi to xn that is our answer. For we have solved simultaneous linear algebraic equations using Gaussian elimination method. Now we see the second question. Explain pivoting in solving simultaneous linear algebraic equation and why it is needed. This is a theory question. In solving simultaneous linear equations, pivoting means rearranging the rows of the augmented matrix to make sure the pivot element is non-zero and preferably large. Pivoting is like rearranging the rows and columns of augmented matrix so that the pivot elements becomes non-zero, and we prefer the pivot element to be large because small values can result in computation errors. Why it is needed? It is needed to avoid division by zero and it is needed to improve accuracy. If pivot is too small, it can lead to round of errors in floating point arithmetic. Ensure proper elimination. There are two types of pivoting also, partial pivoting and complete pivoting. The third question is explain what ill-conditioned simultaneous linear algebraic equation are and how to solve them by refining Gaussian elimination method. An ill-conditioned system of linear equation is where on small change in the input data cause large change in the solution. If we change the input data by a slight margin, the output results in very large changes, which is inefficient. For refining Gaussian elimination, we can use partial pivoting, swap rows to bring the largest absolute pivot element to the diagonal. This improves numerical stability. We can use scaling, scale rows so that all coefficients are roughly the same size. We can also use iterative improvement. After computing an approximate x, check if ax is equals to b. If ax is equals to b, the answer is correct, but if not, calculate residual r is equals to b minus ax. What is remaining? Then solve a delta x is equals to r for correction of delta x. Update the solution x new is equals to x plus a delta x. Repeat if needed. The fourth question is write an algorithm to solve simultaneous linear algebraic equations using Gauss-Seidel iterative method. The algorithm to solve simultaneous linear algebraic equations are: first we start the algorithm, input the number of equations n, coefficient matrix a n cross n, right side vector bn, and tolerance epsilon. We set iteration is equals to 0 and repeat the loop until iteration is smaller than n. For I is equals to 0 to n minus 1, we set sum is equals to 0. For j is equals to 0 to n minus 1, we set sum is equals to sum plus aij into xj. We set new x, a new array we create is equals to bi minus sum divided by aij. We update xi to new x array that we have created, and we set iteration to iteration plus 1. We increment the iteration by 1 and then print final vector x which contain the answer and stop the algorithm. Fifth question is compare Gaussian elimination method with Gauss-Seidel iterative method and explain how to select appropriate method to solve simultaneous linear algebraic equations. The feature Gaussian elimination method versus Gauss-Seidel iterative method are typed. The feature Gaussian elimination method is direct method and Gauss-Seidel iterative method is iterative method. This solves in one go. Gaussian elimination method and Gauss-Seidel iterative method repeatedly refines value. This method is fast, but Gauss-Seidel iterative method is efficient for large system. Accuracy, Gaussian elimination is exact, but Gauss-Seidel iterative method may be approximate. Gaussian elimination use high memory, Gauss-Seidel iterative method use low memory. Pivoting is required in Gaussian elimination, but not required in Gauss-Seidel iterative method. You will use elimination method when you want exact solution or your system is small to medium or your matrix is not too sparse. You will use Gauss-Seidel method when your system is large, your matrix is sparse which means your matrix has many zeros and your matrix is diagonally dominant.